So when we're analyzing feeds using that proximate analysis system, I told you how we really have to account for removal of moisture because we can't compare feeds that are different on moisture content. It messes up the percentages of what nutrients are actually inside that feed. So this is when we start to use terms like dry matter and as fed. So we're going to kind of explore that and talk about how we use that for basic calculations in livestock nutrition. Feed really starts with the assumption that all feeds contain some water. And we know that even if feeds are a little more dry, say a grain versus a grass, we know that grains still have water in them, even if it's a small amount. And the reason for that is that, if we took something that was actually completely void of moisture, so think a spoonful of cinnamon, if you ever watched that YouTube video, trying to swallow a spoonful of cinnamon is a horrific process. And you can't do it, and you need water because it's so dry that it dries up the entire, palate, and you can't actually get it down the throat. And so all feeds contain a certain amount of water. Now, when we're a nutritionist and we're doing any type of energy or proximate analysis, I have to analyze the feed on a dry matter basis, meaning that I don't want water in it. But when I actually go to give that feed to an animal, it has to have water in it. And we can't give an animal a feed with no water. So we call that feed something we give on an as-fed basis. So as-fed basis has water. Dry matter basis has no water in the feed. So the way that we actually do this in real life is that I have a nutritionist, whether that's, we'll use Dr. Phillips or I are in the lab, and we're deciding we need to do some analysis, and we need to compare some feeds. So we're going to start by understanding that, okay, every feed contains water. And if I look at my example below, I've got silage on the left, and I've got some cereal corn grain on the right. And both of those have energy and protein and vitamins and minerals, but I can't actually compare them because silage can be anywhere up to 60–70% moisture, whereas the corn grain on the right might only have 5 to 10% moisture. And so I can't compare them because that water messes up the nutrient percentage. And so if you look at the diagram on the top, what happens is we actually put those feeds into an oven. We dry them out completely, and we figure out how much of the nutrient is left over after we remove the water. And so if we're talking about an as-fed food that we give to an animal, it's going to be much heavier in weight because it's got water in it, there's moisture, but it dilutes the nutrients. Whereas if we look at on the right side of that picture, I pull the water out, a feed that I've placed in the oven is much lighter. We've taken all that water out, it's evaporated, and then we have a very concentrated form of the nutrient that I can use for comparison. And so dry matter would never be given to an animal. It's only used in a laboratory setting for analysis. As-fed is only given to animals in real life, and it would never be used for the basic proximate energy analyses. But without those analyses, we would never actually know what we were feeding animals, and we would never be able to compare and cost compare feeds across different countries or cities or even producers. And so it's very important for us that we have both dry matter and as-fed data on feeds. Now, please make sure that you feel very comfortable with the calculations that are shown on the next few slides because you will be held accountable for these on a quiz. And so they're just basic calculations. I'll talk you through them, but come bug me if you're getting stuck on something or have questions. So you're going to be doing 2 practice calculations today. The first one is you're going to be able to calculate how much dry matter is in a feed. So dry matter is going to be all of the nutrients except for water. So dry matter is just an estimation of all of the nutrients in a feed, subtract the moisture or the water. Then I'm going to ask you to calculate a specific percentage of a nutrient in feed. We're going to use protein as our example today, but you could do this with fat or with energy or with a vitamin or with a mineral. It's going to be the same process. We're just using protein as an example. So when we calculate dry matter, what I'm trying to figure out is how much nutrients do I actually have in a feed without water? I don't want any moisture in it. And so if you're a logical person, you like to work through math, the right-hand side might be a great way for you to do it. If you're visual, sometimes the left-hand side of the slide is a little bit easier to understand. So just pick the method that works for you. Don't feel like you have to use both, or if they both work for you, great. So in this example, we're going to talk through corn silage, and I'm feeding it to dairy cattle. Now, corn silage is only 34% dry matter, and this is something that I would have pulled from a nutritionist textbook. There are book after book after book with hundreds of pages of data tables of nutrient contents for feed that have been done historically. So when you get into Animal Science 230 and Animal Science 330, you'll get a lot of exposure to this. Just know that value would have been pulled out of a book. It would have said this type of corn silage at this type of year, it would be this amount, and so it's just already pre-done for us, which is very helpful. It's just sometimes hard to find that data in a book. So back to my example, corn silage and dairy cattle, 34% dry matter. Now, what I'm saying is I know how much dry matter should be in the corn silage. So then we'll start my example on the left. So I'm a producer. I order 40 pounds of silage, which is not very much if I'm talking about dairy cows, but that's okay. And that 40 pounds of silage, I know, is supposed to be 34% dry matter. Well, I want to know how many pounds of dry matter do I actually have in that dump truck. So I start with 40 pounds. It's all of the nutrients, so carbs, fat, protein, vitamin, mineral, and water. And then I do some math, and I ask myself, okay, I'm going to take the ration pounds, because I know that's 40. This equation will never change at the bottom. I'm going to multiply it by the percent of dry matter that I found from that textbook. I'm going to put it in a decimal basis, and I'm going to multiply that across. And what that tells me is, oh, I started with 40 pounds of feed in my dump truck, but when I take the water out, I actually only have 13.6 pounds of feed. And so that's really important to me as a producer, because if you look at that, I'm actually paying a lot of money for water. And so that helps me start to understand if I was to buy, corn silage from multiple producers, which one is charging me more, and how much of that I'm ordering is actually water and not really any nutrients, because water, I don't need to be paying, premium price for water. I want to be paying for those nutrients, those proteins, the fats, the carbs, the vitamins, and the minerals. Okay, and so that's kind of how we would use the dry matter in real life. Another way that we would use this is in an analysis setting. I could actually figure out, okay, based on this, what is my percentage of dry matter? What am I going to do with that? What am I trying to compare it to? And so there's some other ways that we can apply that as well. This is another example of a dry matter calculation, but this time using alfalfa hay, which is much, much higher in dry matter, meaning it doesn't have as much moisture. So use this as a practice. See if you can get this answer without any help. Now this is really where we start to see the nutritionist application of these calculations. So the first one really just tells us how much dry matter. The second equation we're going to work through today is what percentage of nutrient is actually in that feed. And so we're going to use crude protein as an example today, but you could have put anything in there. Energy, fat, vitamin, mineral, doesn't matter. So the first thing that we're going to do is we're going to go back to our corn silage example. We're not going to change anything because I want to keep this consistent. We're still feeding dairy cows, and we're still at 34% dry matter. But I also looked up in that table and realized, okay, so this specific type of corn silage is 34% dry matter, meaning it's let's say 66% moisture, and it's also 8% crude protein. We're still at 40 pounds for the ration. So if I look at my visual example on the left, I've got my dump truck. I'm starting with 40 pounds of feed, okay? First thing I have to figure out is how much of that in that truck is actually nutrients and not water. So we already did that calculation earlier, right? 13.6 pounds. So then I take that equation one step further because I know, okay, now I went from 40 pounds to 13.6 pounds in my dump truck. I have no more water left. I only have nutrients left. And of those nutrients, I could have picked any one to analyze, we're going to look for protein today. So I go, okay, from that 13.6 pounds, how much of that is protein? So I take that 13.6, I multiply it by the nutrient percentage. In this case, it's 8% because that's how much crude protein is in this corn silage. And I realize that after all of that work, right, of hauling 40 pounds of feed to myself, only 1.08 pounds of that is crude protein. Now, that's pretty normal, okay, because crude protein tends to not be very high in feeds. It's very expensive. And maybe I have, 2 bags of corn silage, and one of them is a little bit higher in protein and not as expensive. And this is how I would start doing that. So I could actually take that crude protein value we just got on a weight basis, and I could start doing some cost analysis, or I could start doing just basic crude protein comparison. And so this is really important to understand that there's a lot of calculations that go on behind the scenes of how we calculate diets, and why we have to pull water out in order to kind of do the comparison, because water dilutes the percentage values or the weight values that we're trying to calculate. And so we always deal with dry matter first. We take the water out, and then we sit there and we think about, okay, what am I looking for? Do I want to think about protein? Am I trying to cost compare energy? What am I trying to do here? And then we would do a second calculation to figure out that percentage. So there's another example calculation on the next slide. Use that as an example. We're using alfalfa hay again. See if you can work through that on your own. And if you've got questions, come bug me. Otherwise, this is the end of our lecture for this week. We'll